Okay, this is the second part of the video. This is all to do with hydraulic machines. This is a great application of where we can use pressure, and we can use it in hydraulics. And you may have occasionally may have heard that you can have firefighters on a scene of a major car crash. Somebody's trapped a car, and what you can do is use hydraulic cutters to actually cut the top of the car off, is basically slice through the metal. And what they can do then, if anybody's trapped inside the car, they can then save them. Obviously, not being good at being stuck inside a car. Hydraulic cutters are very, very powerful, and they're force magnifiers, and this is how they work. So I want to imagine you've got syringe A and syringe B. You've got a tube then connecting the two together, and you've got liquid inside A and liquid inside B. And here's your liquid running along through here. And if you then push A that way, what then pushes B out that way. You can also, of course, choosing a different color pen, is push B this way, which then pushes A out that way. So therefore, you can make the move back and forwards. But you will find that this one, A, requires a very, very small force compared to B. And there's a reason for this. And the reason comes down to the equation pressure equals force divided by area. Now, the pressure in A and B has to be the same because you've got the same liquid running through. Therefore, if you look at A, the pressure is equal to the force in A divided by the area in A. But in B, the pressure is going to equal to the force in B divided by the area in B. Now, looking at these two diagrams, I want you to see the fact, going back to my red pen, hopefully, is in A, I have got a small area because it's a smaller syringe. Therefore, the force is going to be small. But in B, the area is going to be larger. Therefore, the force is going to be larger. It has to be this because the pressure has to keep the same in each one. Therefore, you'll find A requires a small force for it to move, where B requires a large force. And if you really think about it, if B has twice the size of the area, wouldn't the force be twice as big? If the area B was 3 times, wouldn't then the force be 3 times? We're making a force multiplier. A small force in A makes a big force in B. Now, where you can use this is something like this. Now, here are these hydraulic jacks. What we've got is a great big cylinder, and it's got liquid inside, and liquid is shown in green. And you can push down here on this piston, which makes this piston then go up. But if you notice, the area here is a lot smaller than the area there. Therefore, it makes the force bigger. I can show how much bigger the force is by using the equations, because you know pressure equals force divided by area. Therefore, on this one, the force is going to be 50, but they've given the area in centimeters squared. Fine, I can put that as 10. Just going to be careful, my units now is going to be newtons per centimeter squared. Therefore, this one, by rearranging my equation, I know F is equal to P multiplied by A. Therefore, now the pressure is going to be 5 multiplied by the area, but our area now is going to be 200 from here. Therefore, multiplying the two together is now then going to be 1,000 newtons. You can see now the force is a lot bigger. But you can also see, isn't the area going to be 20 times bigger, 10 to 200? Okay, therefore, isn't it simply taking 50 multiplied by 20, which again equals 1,000 newtons? That's the proper way to do it using a formula. But it's a quick way of looking at it and see as if that's a force multiplier. Another common application of this is in car brakes. In your car brakes, here's your mum and dad driving a car and trying to stop the car. First of all, you've got the pedal, which they push on that way. You've then got a lever device here because here's your pivot. You're pushing it with a distance, therefore it's a lever again and make it a force multiplier by the force put in your foot. But then you're pushing in and you basically are making a piston close on something called a master piston. Then in here you've got your liquid. The liquid goes all the way along here, all the way down like that. And then it's connected to two slave pistons. Now here's your wheel, which is going round and round and round, and you want to make it stop. Therefore, you've got a braking disc just here. Here's your braking disc. Now, basically, when all the liquid's pushed through, one brake pad goes that way and one brake pad goes this way. And what it does then, it puts the brake pads onto the disc. But if you look here, the area is small and here the area is big. Therefore, it's a force multiplier. If that was then going to be 3 times the area, wouldn't you make the force 3 times bigger? Hence, a small force here can be a lot bigger to stop the wheels turning. And we have to use liquid here because what you should know is liquid cannot be compressed. Otherwise, you can push and push on this and you can't squish liquid and closer together or the particles inside it. Therefore, it works perfectly. But what can happen with time is you can get tiny little air bubbles inside the liquid. Now you should know that gases can be compressed. Therefore, with time, you have to bleed brakes, and what you do is get all that air or little bubbles out of the liquid, because if we don't take the air out, it becomes very spongy. Recently, I had some mountain bike which has hydraulic brakes. It became very spongy brakes. They weren't working very well, and all I did was bled the brakes by basically making sure all the liquid's going to be in the tubes, and therefore what happens then is your brakes work very effectively. There have been a few films, like in case of James Bond, where your evil villain has come along and has cut the pipes in James Bond's car. So when he puts a foot on the brake, all the liquid starts squirting out. Therefore, you don't transmit any pressure. Therefore, the brakes don't work. And that's why cars need to be maintained. Now, what I've uploaded for you on the Edmodo post is also this lovely little worksheet, which you can work through. And hopefully now you'll understand everything on this, what I've been explaining to you today. Okay, hope you enjoyed my little video. Bye for now.